Hello everyone, in this video we're going to talk about momentum and collisions. So in our syllabus, we are only talking about linear momentum, which is m times v, and momentum is a vector quantity, so the direction matters. If to the right is positive, to the left must be negative, and momentum is always conserved in collisions. The momentum before the collision equals after the collision. So for example, we have like a car 1000 kg mass going 30 meters per second, which is around 108 kilometers per hour, and we have like a truck fully loaded 20,000 kg going slow 5 meters per second to the left, so around 18 kilometers per hour to the left, and they crash into each other, and the momentum of the car is 30,000 because 1000 times 30, and the momentum of the truck is 20,000 times 5, which is minus 100,000. Therefore, the total momentum before the collision is minus 70,000. So 70,000 to the left. After the collision, let's say the car is rebounding, so it's bouncing back to the left with speed 90 meters per second, and the truck to the right 1 meter per second. So you see the momentum is minus 90,000 plus 20,000, which is minus 70,000. So the momentum is conserved before and after the collision. Kinetic energy is 1/2 mv squared. Is a scalar quantity. It's always positive and no direction, and is conserved only in ideal situations called perfectly elastic collisions. So for example, here we have the mass 2 kg, 3 kg. Before the collision, the 2 kg is going to the right, the 3 kg to the left, 5, 10 meters per second. The momentum is therefore 2 times 5, 10 to the right, 3 times 10, 30 to the left, and the kinetic energy before the collision is 1/2 times 2 times 5 squared, which is 25, 1/2 times 3 times 10 squared, which is 150. So the total momentum before minus 20, the total kinetic energy before 175. After the collision, the 2 kg is going to the left 13 meters per second, the 3 kg to the right 2 meters per second. The momentum is therefore minus 26 plus 6 minus 20. So you see the momentum is conserved before minus 20, after also minus 20. But now the kinetic energy, 1/2 times 2 times 13 squared, that's 169. And for the 3 kg, 1/2 times 3 times 2 squared, so that is 6. The total is also 175. So in this case, kinetic energy is conserved. The kinetic energy before equals kinetic energy after. So this is the ideal perfectly elastic collision. The energy is exactly the same. But kinetic energy is not always conserved. So same example. So usually some energy is lost, so that for example here the speed is 7 to the left, 2 to the left, which means the momentum is minus 14, minus 6, minus 20. Again, the momentum is conserved, but the kinetic energy, 1/2 times 2 times 7 squared, that's 49, 1/2 times 3 times 2 squared, that is 6. The total is just 55. So before the collision 175, after the collision 55, which means 120 joules is lost in this collision. So it is not converted back to kinetic energy. So this is the usual realistic case, because energy is never really conserved 100%, especially when the bodies coalesce. Coalesce means they stick together. So after the collision, the 2 kg stick together. They are moving to the left at 4 meters per second. So the momentum is 5 times 4 minus 20. Again, momentum is conserved, minus 20, also minus 20, but energy is not conserved, 175, 40. So this is actually the lowest possible kinetic energy after the collision. So that is when they stick together. This is called perfectly inelastic, or this is just the worst kind of collision in which the most amount of energy is lost. That's it. I'll see you again next time.